Hello everyone. In today's video, we are going to learn how to solve problems based on non-right angle triangles. For right angle triangles, I have already covered a video where we learn Pythagoras theorem and trigonometric ratios. We learn the Soka-Toa method, but that is only applicable to right angle triangles. But for non-right angle triangles, we are going to learn sine rule and cosine rule today. So without wasting time, let's do some math. First, we'll learn the basic difference between the sine rule and cosine rule, that how it is different and in which case we have to use the sine rule and in which case we have to apply the cosine rule. So let's check. Okay, so both sine rule and cosine rule is applicable to non-right angle triangles. We can start with the sine rule. What is sine rule? So basically, when we have a non-right angle triangle, and both the cases are also applicable to right angle triangles, but it's easier to solve problems using Pythagoras theorem and the trigonometric ratios. But sine, when we have non-right angle triangles like this. So this is a triangle ABC, and if two sides and one angle is known to us, or two angle and one side is known to us, then we can use the sine rule. These are the three vertex of the triangle A, B, and C. The opposite side is labeled with the same letter but with the smaller letter. This is C, so that is A. So this is side A. It says A upon sine A, where A is the capital A is the angle. So A upon sine A is equals to B upon sine B, which is equals to C upon sine C. So whenever we have two sides and one angle known, we can use the next angle basically. But let's take an example to understand this better. So for example, let's say this side A is 10 centimeter. This angle is, let's say, 65 degrees. This angle is, let's say, 48 degrees, and this length B we have to figure out. That means we can take sine, and this formula can also be written as sine A upon small a is equals to sine B upon small b equals to sine C upon small c. That means we can write sine 48 degrees upon 10 is equals to sine 65 degrees upon small b, which we have to find. So we can make b the subject of the equation. B can be written as sine 65 degrees multiplied by 10 whole divided by sine 48 degrees. And when we will solve this, let's do this in calculator. So 10 multiplied by sine 65 divided by sine 48, and I'm getting 12.19. So I can write it as 12.2, correct up to 3 significant figure. So B will be 12.2 units, and that's how we use sine rule. What about cosine rule? Let's check cosine rule now. So for cosine rule, again, we label the diagram exactly the same way. So this is A, so the opposite side will be small a. This is angle B, so this opposite side will be small b. And this is angle C, so the opposite side will be small c. So here the formula is A square is equals to B square plus C square minus 2BC cos A. I can write down the formula here. Just a second. Yeah. So it is A square is equals to B square plus C square minus 2 multiplied by B multiplied by C multiplied by cos capital A. This is in which case? In case where angle A is known to us and the length C and the length B is known to us and we have to work out the length A. So in that case we can use this formula. But in case if let's say angle B is known to us and we have to work out side B, condition the length C and B is known to us. In that case we can write the formula as B square is equals to A square plus C square minus 2 multiplied by A multiplied by C multiplied by cos capital B, which is the angle. Similarly, when we have to find the other side, let's say C, so C square will be A square plus B square minus 2 into A into B into cos C. So this is how we use the cosine rule. This can also be used to find the angle. That's the other case when all the three sides are known to us. When all the three sides are known, side C, side B and side A, and if we have to find any one angle, so in that case we can again use cosine rule. We can make, let's say if we have to find angle A, we can make cos A the subject of the equation and we can substitute the value of A, B and C and minus 2BC, and we can make cos A the subject of the equation, and that is how we can find the value of cos A, and then A equals to cos inverse the solution. That's how we can find the angle A. So we'll solve a few questions to check and to practice and to see how we can solve these questions based on sine rule and cosine rule, or we can say non-right angle triangles. So let's start from question number 1. We'll start from basic questions and then we will check more advanced problems. So we'll go a little faster now. We have it says the diagram shows triangle ABC. We have triangle ABC. We can clearly see that angle A is 134 degrees. The opposite side is given to us. Angle C is given to us, and they're asking us to find the length of side AB, which is the opposite of angle C. So here we can quickly apply the sine rule. We can write sine A upon A is equals to sine C upon C, which is actually the AB length that we have to work out. So sine A, we can write sine 134 degrees divided by 10.2, which is equals to, we can write sine 28 degrees divided by the length AB. So we can make AB the subject of the equation, and then we can write sine 128 multiplied by 10.2 divided by sine 134 degrees. We can do this in calculator and get the length AB. So 10.2 multiplied by sine 128 degrees divided by sine 134 degrees, and the answer is 11.137. That's AB. But in the question it is clearly mentioned that give your answer correct up to 3 significant figures. So we have to write the answer correct up to 3 significant figures. That means 11.1. That's the length of AB in centimeters. So write 11.1, and that's the answer. Let's move on to question number 2 now. So question 2 is here. It says the diagram shows the triangle ABC. Calculate the length of BC and give your answer correct to 3 significant figures. Again, we can check clearly that the angle A is given and the opposite side BC is missing, which we can label it as A, and AB and AC is given to us, which is exactly opposite to angle C and exactly opposite to angle B. That means here we have to apply cosine rule, because the sine rule will not be applicable. If we do sine A upon A and sine B upon B or sine C upon C, we have 2 values missing, so we cannot apply sine rule in this case. We have to apply cosine rule. So here we can write A square is equals to B square. So this is B, side opposite to angle B, plus C square. This is C, side opposite to angle C, minus 2 times b into c cos capital A, which is the angle. And now let's substitute the values. So a square is equals to 6.4 square plus 4.8 square minus 2 times 6.4 multiplied by 4.8 cos capital A, which is 123-degree angle. So let's solve this. A square will be, we can do it in the calculator, 6.4 square plus 4.8 square minus, now do all these calculations, all of these calculation inside the bracket. So minus inside the bracket 2 multiplied by 6.4 multiplied by 4.8 multiplied by cos 123, bracket close, and my answer is 97.4626 and so on. So A will be under root of this answer. So you take under root of answer and I'm getting 9.872. But it says write correct up to 3 significant figures. So I'll write A as 9.87 centimeters. And that's my answer, the value of A. Let's quickly move on to the next question. Question number 3. Question number 3, it says the diagram shows triangle GHI, GHNI, and it says calculate the length of GH. So this is the side GH, this we have to find, which is opposite to angle I. So I can mark it as I over here. And can we apply sine rule here? We cannot, because if we do sine H by H and sine G by G, there are two values which is missing, so we cannot. But we have two angles given to us, that means we can find the angle H. So angle H will be 90 degrees minus sum of these two angles, which is 73 plus 26. So angle H is going to be 90 minus 73, sorry, not 90, it is going to be 180 degrees. Angle sum property of the triangle is 180. So 180 minus 73 minus 26, and that is 81 degrees. So angle H is 81 degrees. I can write 81 degrees over here, and let me write it here to save the space. Now we have to find the length of GH, which is this length. Now can we apply the sine rule? Let's check. Sine 26 upon I, we can write sine I upon I is equals to sine H upon H, and that's how we can work out the value of I. So sine I is sine 26 degrees divided by I, which is GH that we have to work out, which is equals to sine H, which is sine 81 degrees divided by H, that is 13.5. So we can make GH the subject of the equation, and we can write sine 26 degrees multiplied by 13.5 divided by sine 81 degrees. So that is, let's do this in calculator, 13.5 multiplied by sine 26, which is this much, divided by sine 81, and the answer is 5.5991. That's GH, but we again have to write the answer correct up to 3 significant figure. So the answer is going to be, GH will be 5.99 meters, and this is the final answer, 5.99 meters. Let's move on to the next question now. Question number 4, it says the diagram shows the triangle DEF, DE and F. Calculate the value of X. Now the X is angle X marked in the triangle. So can we use sine rule here, because we have 97 upon the 97 degree and the opposite side, and this angle X and the opposite side is known, so we can use the sine rule again here. So we can write sine 97 degrees divided by 8.1, which is equals to sine X divided by 6.7. So we can make sine X the subject of the equation, and we can write it as sine X is equals to 6.7 multiplied by sine 97 degrees divided by 8.1. So we can write sine x is equals to, let's do this in calculator, 6.7 multiplied by sine 97, which is this much, divided by 8.1, and the final answer is 0.82099 and something. But we have to find the value of x. We have sine x right now, so we can write x as sine inverse of 0.82099, and let's keep the value exactly like this in the calculator, and just do sine inverse answer and you will get the value. So x is 55.184. We have to write correct up to one decimal place this time. So x is equals to 55 point, next to 1 we have 8, so we can write 55.2 degrees. So that's the answer, 55.2 degrees. That's the value of x. Let's move on to the next question now. Question number 5, it says the diagram shows triangle MNO. Calculate the size of the angle MNO. So NMO, which is angle X, that is marked in the triangle, marked as X. It says give your answer correct up to one decimal place. So now in this case we have to find this. Again, can we use sine rule here? Sine 62 by this? No. This angle is not given. Okay, but we have these three values given: this side, this angle, and this side. So we can find the opposite side, which is MN first. Let's mark MN as small o. So we can write O square is equals to opposite of angle M is small m. So we can write M square plus this will be N because opposite of angle N. So N square minus 2 times M into N cos angle O. If we do this, we'll get the value of Mn first. So O square will be M square, that is 10.8 square, plus N square, that is 12.9 square, minus 2 times 10.8 multiplied by 12.9 multiplied by cos 62 degrees. So let's do this in calculator to find the value of O square first. So that is 10.8 square plus 12.9 square minus, now do this calculation in the bracket, minus inside the bracket 2 times 10.8 multiplied by 12.9 multiplied by cos 62 degrees, bracket close, and the answer is 152.236. Under root of this answer, which is O, that is 12.34, we can write 12.34. This is 12.34. We have to work out the size of angle X. So now we can apply sine rule here. We can write sine X upon 10.8, which is equals to sine 62 degrees upon 12.34, and we can work out the value of X here. So sine X is equals to sine 62 degrees multiplied by 10.8. Just a second, I think I should not write here. I'll do it here now. Yeah, so sine 62 into 10.8, and then we already have 12.34 in the denominator. If we'll do this, we'll get sine X is equals to, so let's multiply 10.8 with sine 62. This is the answer, and then divide by 12.34. The answer is 0.7727. So X will be sine inverse of this answer. So shift sine inverse answer, and we are getting 50.6 exactly, approximately correct up to one decimal place. The answer is 50.6 degrees, and this is the answer. So this is how we use sine rule and cosine rule to work out the length, the missing length or the missing angle of a non-right angle triangles. With this, we'll end the video here. If you find this video useful, you can also share it with your friends so they can also learn it. If you have any other preference of any other topic, do share it with me. That's all for today's session. Bye everyone.